It says, given that u is equal to x plus one, express that in terms of that. Okay, so that's not too bad. That's just a bit of algebra, right? So doing that, if u is x plus one and I express x in terms of u, right? Then that would mean that x is equal to u take away one, isn't it? So if f is equal to that, then I'm going to say f then will equal x, which is u take one, and then the square root of x plus one. Yeah. Now the square root of x plus one. So x plus one itself was what u is equal to. So that's just going to be u, isn't it? So that means I get part A. Does that make sense? Happy with that, guys? Yeah. Good stuff. And then part B, just make sure we're all okay. Part B says, hence show that f is equal to that. So this is what f is so far, like that. What I'm gonna do is rewrite u, right? As rewrite root u as u to the power of half. I'm gonna put it to the front though. So u to the half, and then you take one. These two are the same thing. If I expand that, that's a one, isn't it? When I add those together, that's gonna be 3/2, and then take u to the half. So we've done it. That's part B. That's fine. And then what was part C? It says, given that u equals x plus one, so that du over dx is equal to one. And then by treating du over dx as a fraction, express dx in terms of du. Okay, so that's not too bad. I'll do it here. So u is equal to x plus one. Du dx means I differentiate with respect to x. So that's going to be du over dx. We know that x differentiates to one differentiates to zero, so that's fine. And now if I treat that as a fraction and I want dx in terms of du, then I'm just going to multiply both sides by dx, aren't I? So I'm going to get du is equal to dx. So did we get that for dx? Dx is equal to du. Did we get that? Good stuff. Brilliant. And then it says, hence show that the integral of x root x plus one, right? Dx is equal to that. Let me just say a message. Would you not have to use first principles to show that? Would you not have to use first principle if it says show that? When you say first principle, are you talking about differentiation? Differentiation from first principles. Oh yeah, no, this is just a 1 mark question, right? So because of the mark allocation and it will say, and the question would say from first principles. That's what it would say in an exam. If they want you to use first principles, they would explicitly state it. So because it's only 1 mark and I haven't stated it, then you don't need to use first principles. Yeah? Good stuff. So we know that dx is du, and then it says hence show that the original integral, right? X root x plus 1 dx is actually equal to that. Well, remember what we did in part A is we said that this here was already equal to u to the 3/2 minus u to the half. So I don't need to do that again. Now we said that dx is du, so I can just put a du there. And that's double I. Yeah, because there's no need for me to do this again because I did it over there, didn't I? Yeah? Happy with that, guys? Oops. Yeah, good stuff. And then three over there. And then part triple I says, hence evaluate the integral in terms of u for 2 marks. Okay, well, what have we figured out? We figured out that this integral is actually just the same as u to the 3/2 minus u to the half du, isn't it? Yeah. So what we're gonna do is just integrate that. Now, this is a polynomial type of integral. We're gonna add one to the power divided by the new power. So it becomes u to the, if I add 1 to 3/2, it'll be 5/2. Divide by the new power, it's going to be 5/2 like that. Minus u to the, add 1 to the half, it's going to be 3/2, then over 3/2. And then now we're dividing by a fraction, we can times by the reciprocal. So it becomes 2/5 u to the 5/2 minus 2/3 u to the 3/2. Anyone get that? Is that the final answer? Would I get full marks in the exam if I write that in the exam? Why wouldn't I get full marks? Exactly. Well done, guys. Don't forget your plus C. Yeah? I did that on purpose. Yeah? Never forget your plus C. Otherwise, they won't give you the marks. Well done, Cyril, Maury, Samuel, Alfie, Keshan. Good stuff. Yeah? So, what have we done here? Essentially, we started off with some integral, right? Which was in terms of x. Now, what happened is that we used algebra and manipulation to rewrite this integral into another variable, u, yeah? And that is what integration by uh Integration by substitution is yes. So Ramon, you're right. I'm gonna get onto that just because I'm teaching it for the first time. But yeah, that is definitely correct, 100%. Right? So basically we were here, and in the exam you'd have this. You'd have x root x plus one dx, right? And they could say, for example, u is equal to x plus one and find out that integral. And basically what the whole concept and logic with integration by substitution is that at first you have some integral in terms of x, which is very difficult to integrate, right? So you use a change of variables, in this case u, to rewrite your integral in terms of that variable u. And what you should hope for is that the integral that you get when you change the variables is a lot simpler to work with. So what we've realized, or what we've seen, is that this is actually the same as working out the integral of u to the 3 over 2 minus u to the half du, right? So we integrate the right-hand side because it's easier to work with, but you're not finished, right? Because this is your original question. Yeah, this is your original question. So we were here, guys, and I'm saying that this is not the final answer. So what do you think the final answer would be? This is for anyone that has or has not done integration or substitution before. The question in the green brackets is your question, right? When you integrate something with respect to x, what variables should you have as your answer? Exactly, Samuel, right? You have to put X back in. So in an exam, you would never, ever, ever leave your answer like this. Never. What you would do is say, fine, that is this one here. And then we know that U is X plus one. So your final answer is going to be 2/5 X plus one to the 5 over 2 minus 2 over 3 X plus one to the 3 over 2 plus C. And that would be your final answer. Does that make sense, guys? Put a zero if you don't get this at all, or put a 10 if it's very makes perfect sense. See a 9, 10, and 8. Good stuff. All right, brilliant. So let's do a couple of examples and see how we get on. Now, let's just read what this says. It says here that sometimes you can simplify an integral by changing the variable. The process is similar to using the chain rule in differentiation, and it's called integration by substitution. In a sense, where when you're first taught the chain rule, when we did it in September, we said that we're going to let something equal u and then use algebra and differentiation to rewrite it, right, into something more easier to differentiate. Integration by substitution is the same kind of process. So let's have a look at a couple of these examples here. So it says find the integral of x and root 2x plus 5 dx using the substitutions. And we've got two options here. Now, sometimes when you do a couple of them, you'll actually start to notice is that you can actually use different substitutions, right? But a rule of thumb is whenever you see something like this and you've got like a square root here, always make this the substitution. Yeah? That's what always happens. That's just the general thing. But once you do a lot more practice, you'll be able to see. So let's do this one. So firstly, u equals 2x plus 5. And remember, your job is to rewrite this integral here, all in terms of the variable u. So firstly, if u equals 2x plus 5, then I could immediately say, well, I've got x here, and then that means I've got u there, and then dx. Does that make sense so far, guys? You're just basically building it up. Yeah. U equals 2x plus 5. I've just replaced 2x plus 5 with u. That's not a problem. Yeah. Okay. Now, what else do I have? Well, I've got an x there. I don't want an x. I want a u. I need to get x in terms of u. So if u equals 2x plus 5, that means that u take away 5 is 2x, obviously. And that means that x must be equal to u minus 5 divided by 2. And then I can update that a bit more. So I can say that we've got u minus 5 over 2. I've got that root u over there, and I've got dx. Are we happy with that so far, guys? Does that make sense? Yeah, good stuff. And then now, the problem is that this dx here. Now, the way you get rid of this dx here is by differentiating, right? How can I get an expression for dx? You're going to differentiate this. So du over dx will equal, because somebody tell me what du over dx is? Thank you very much, Keishan. Alpha is just 2, right? And you always treat this as a fraction that can be separated to isolate the dx. So in that case, that would mean that du over 2 will equal dx, wouldn't it? If I divide by 2 times by dx, and that means I can put this in here. So u take away 5 over 2 root u, and then dx is du over 2. And now can you see it's all in terms of u. So now I'm ready to start. Maybe not integrating yet because there's a bit more I can do, but at least there's no x's anymore. This is what my expression is going to look like. Now we need to tidy up a bit. So what I'm going to do is say, okay, well, fine. I've got a half there and I've got a half there. I can write those two as a quarter. Put that there. And then obviously that one over there, this one is u to the half. So I'm going to put u to the half there. And then I've got u take away 5. And then I've got it with respect to u, du there. And then now I'm going to expand that. That will give me a quarter. And then it's going to be u. It's going to be a quarter u to the 3 over 2. Like that. If I expand that and that, let me just double check. Yeah, that's fine. And then minus 5 quarters u to the half du. And now we're in a position to integrate, because if you compare what we had before, it was quite messy. The surds here, square roots, is not nice. We're saying that this integral is just the exact same as integrating that, which is a polynomial one. You just add the power and divide by the new power. Are we happy with that, guys? Does that make sense? Just before I continue? Yeah, good stuff. So now I'm gonna say, okay, well, fine. I've got a quarter. I've got a quarter there. Gonna have u to the 5 over 2. I'm gonna divide by that new power, like that. And then I've got minus 5 quarters. I've got u to the 3 over 2. And I'm going to divide by the new power plus c. And then now I need to tidy that up. I've got a quarter divided by 5 over 2. That's just a quarter times by 2 over 5. Like that. And then this one is u to the 5 over 2. And then minus, and then 5 quarters times by 2 over 3. U to the 3 over 2 plus c. And let's tidying that up. That's just going to be a fifth, isn't it? 2 over, no, 2 over 20 is a tenth, sorry. It's going to be a tenth. And then u to the 5 over 2, like that. And then minus, and then that's going to be 10 over 12. 10 over 12, which is the same as 5 over 6, isn't it? When I divide top and bottom by 2. So like that. 5, 6. And then u to the 3 over 2 plus c. Does that make sense, guys? Yeah? All good? Good stuff. And then now remember, your question was originally an integral in terms of x. So we need to keep it that way. So I'm going to rewrite this with x. Now remember, u was 2x plus 5, wasn't it? Yeah. So if you use 2x plus 5, that means it's just 1 over 10, 2x plus 5, 5 over 2, minus 5, 6, 2x plus 5 to the 3 over 2 plus c. And that's it. Makes sense, guys? Let me do so much so you can see all of the work in. All good? Yeah? Okay. Let's do this one here, which is a different type of substitution, but still the same thing. So I'm going to write this here. So I'm going to have this integral of x and then 2x plus 5 dx, like that. And the substitution is u squared is 2x plus 5. So in that case, right here, u squared is equal to 2x plus 5. All right. Now, firstly, if u squared is 2x plus 5, then that means I could write this as x and then the square root of u squared, like that, dx, because that's 2x plus 5. And then the square root and the square will cancel. So right now it's just x u, isn't it? dx. Right? So this one allows us to get rid of that square root, right? This substitution. Now, what I need to do is like, I'll find, well, also, let me figure out what dx is as well. So I've got u squared, and I need to figure out what dx is. So I need to differentiate with respect to x, but we've got u squared here. So when I differentiate this with respect to x, guys, could somebody tell me what I get? This is another topic in differentiation that you may or may not have done yet. The initials of the topic are ID. ID. Anyone know what I'm talking about? Fantastic, Alfie. It's implicit differentiation. Have we all done that before? Anyone not done it? Okay. No worries. I'm gonna do that in January. But basically, implicit differentiation is when you have a function of another variable and you differentiate with respect to another letter. So, for example, x here. What you do is you differentiate this. So if I differentiate this, it'll be 2u, and then you just multiply by du over dx. So this is the chain rule. So don't worry if you haven't seen this yet. I'm definitely going to do a lesson on this. Yeah? So 2u du over dx, and then this is equal to that there is going to be just 2, isn't it? Yeah? And then that way, that means that the x then, right? Let me just tidy it up. That means that 2, or I can divide by the 2's. So it becomes u du over dx is equal to 1. And that means that dx then is just u du, isn't it? If I times by that. So that means I can put this in there. So I just put this in there. So it becomes x, and then it becomes u, and then it will become dx, which is u du. Does that make sense so far, guys? Just before I continue? Yeah? And then now, we need that x is still there. We don't want the x, so we're going to rearrange this. So now it becomes, let me put this here. You know, I'll just copy it to be fair. Copy that. And then that becomes, u squared take away 5 is equal to 2x. That means that u squared take away 5 over 2 is x. So I can put that in there. So the question becomes, x, sorry, not x, because I'm going to change that. It's going to be u squared take away 5 over 2, right? And then I've got the u there, and then I've got u du, like that. Does that make sense, guys? So far? Before we continue? Yeah? Good stuff. Good stuff. Okay, so let's tidy all of this up then and see what we get. So, I've got a, what's this? Okay, hold on. Let me just see. Okay, I need to move it just a bit more to the side so it just doesn't go there. You just move this to the right. Okay. So tidying this up, I'm gonna have that half, I'm just gonna write like that. And then I've got u squared take away 5. And then I've got u squared like that, don't I? And then du. And then expanding that, I'm gonna have I'll write it like this, a half u squared, and then u squared take away 5 du. I just brought these two together. So that one and that one there, I brought together at the front. So now I'm going to expand that. That's going to give me a half u to the 4 minus 5u squared du. And then now I'm in a position to integrate. So doing that will give me um a half, add 1 to the power of 5, divide by the new power of 5, minus oh sorry, I just realized I forgot to do 5 over 2, didn't I? A half times 5 is 5 over 2, so there should be a 5 over 2 there. Does that make sense, guys? Yeah, all good? Okay. So I'll just do it again. So this one here is a half u squared times by u squared. That's going to be a half u to the 4, that one there. And then when I do a half u squared, I'll do it here. A half u squared uh times by 5 or minus 5, right? A half times minus 5 is going to be minus 5 over 2. And then I'm going to get u squared. Does that make sense now? Where did the other u squared come from? So that came from there, didn't it? So remember, we had u and u here, u and u there. That's where it came from. So it was already there. There was a u there already, right? And then when I did the differentiation, I had the u du. Yeah? Cool. So that's where the u squared came from. And then now I'm here. Now I can continue. So it's going to be 5 over 2, and then u to the 3 over the new power plus c. And then if I do that, that's going to be 1 over 10 u to the 5 minus 5 over 6 u to the 3 plus c. Now remember what u was equal to? U was equal to, or u squared, I should say, was 2x plus 5, wasn't it? So if u squared was 2x plus 5, right? Then u, right, is going to be equal to 2x plus 5 to the power of 1/2 for the square root, right? Now, if I plug that back in, that's going to be 1 over 10, and then it's going to be 2x plus 5, all to the power of a half, all to the power of 5, right? Minus 5 over 6, and then 2x plus 5, all to the power of a half, all to the power of 3, plus c. And then now we've got a power of a power. You can say this is 1/10, 2x plus 5 to the power of 5 over 2, minus 5 over 6, 2x plus 5 to the power of 3 over 2, isn't it? Plus c. And that is exactly what we got before, isn't it? Where is it? Yeah, can you see? That one there, and then that one there. These are exactly the same. So you can see that you could use different substitutions for the same question, but you get the same thing. So it just depends on what you prefer. Yeah, and to be fair, in an exam, I've never seen them not give the substitution, but it can happen. Yeah, but does that make sense, guys?